Hi, Professor. This is Girish Kumar, and I have my companion Vishnu Monish Kankanala in the call in the same meeting. Today, I'm going to explain ICP-10, which has to be done on CIFAR-10 dataset for image classification. Uh, so, first of all, we are importing the required libraries of Keras and the NumPy to build a convolutional neural network. On top of it, the sequential layer again. And in the next cell, I'm importing the SSL library to bypass SSL certification error, as my certification is expired, so I just want to bypass it. So I'm taking the SSL library here to download the CIFAR dataset. The next cell, I'm downloading the CIFAR dataset as a train and test separately. And then we are normalizing the inputs by just changing the data type and normalizing the inputs, by dividing 255.0. What it does is it will just convert the colored image to grayscale image. And here I'm checking the shape of the train data so that I can give the same to the first layer of my convolutional net layer. And then we are converting the numbers of the labels to 1 hot encoders so that we can use them for training our model CNN. And here I'm checking the number of classes at 10 so that we can have the same number of neurons in the output layer to just cross check. Here I'm creating the CNN model, the first, and then I'm creating the sequential layer on top of it. So here, so I'm using the activation function as ReLU in all the convolutional layers, and then dropout using the dropout layers in between as 20%. And the kernels has 3x3 filter, and the padding is the same as we got the input image. And after the 7 convolutional layers, I'm using the flattened layer here, and on top of it I'm using the dropout percentage 20, and then the sequential layer, dense layer with 1024 inputs, and then the dropout 20%, and then the dense layer with 512 inputs with the activation function as ReLU, and then the dropout function as 20%, dropout layer as 20%, and then the final output layer with the activation function as softmax, and the number of neurons gonna be 10, as we have the number of classes are 10. Here I'm initializing the number of epochs to be trained and the learning rate, and I'm just using the learning rate in the Atom, which is optimizer. I'm compiling the model here with the metrics as accuracy, the loss function as categorical cross entropy. Here is the summary of the model. Can you go ahead? Can you scroll up? Yeah. Yeah, here I'm training the model with the trained data uh, with the number of epochs 10, and the batch size for each epoch is 128. And then we can see here the accuracy started from 0.2 until 0.7981, 82 even, and the validation accuracy we have reached is 0.77 on the test data. And we can see the model, the same percentage here when we evaluate with the test data, that is 77.75% is accuracy on the test data. So here I'm just visualizing the model of the Keras in the graphical view. And then this is the second task, which we have to convert the sequential layer model to functional API. Here, what I'm doing is I'm just initializing the input layer separately, and then linking the convolutional layers and the dropping layers, max pooling layers in between. And finally, I'm mixing them using the model here by just passing the input layer and the output layer to the model function. Uh, Scroll up, please, Vishnu. Yeah, the optimizers and the compiling method are the same as we have used above. Here I'm adding the callback and early stopping for saving the model in using the model checkpoint and early stopping to avoid if the performance is not improved, we can just avoid it, so that it won't take, if there is no improvement, it won't try again and again to avoid the warfitting as well. So here I'm using in the callback as a parameter to train the model. Yeah, so we can see here the accuracy has gone till epoch raised till epoch 10, and the loss here is less, and the validation accuracy is 0.79. That is what we have achieved at epoch 10. After that, there is no improvement, and the validation accuracy did not improve. That is a 0.79. After that, there is no improvement in the validation accuracy, and the best model we got is at epoch 10. So here is a validation accuracy, the loss, and the training accuracy in the same plot. uh, we can see the training and the validation accuracies reciprocated each other. That means the model is performing good on the test data. And the loss, we can see it has fallen from 1.6 to 1.4, which is pretty good. And here, from here, my companion Vishnu Monish will take over. Vishnu, go ahead. Thank you.
Hi, Professor. So from here, we are first predicting the first four images of the test data. So we are printing the test label at index 0, and we can see the original index output where the fourth element is 1 and rest of them are zeros. And then we are predicting the probability and printing the index of a class. So we can see the probability is at 0.77 and the index, we are printing it integer 64 data type. And then we are printing the test label at index 1. So now the position of element 1 has changed from 4 to 1, 8th element. You can see in the original index array 8 and data type is integer 64. And then we are predicting the probability and printing the index of the class. So you can see the probability is shown as 0.964 and index is at array 8 and data type is in 64. We are then printing the text label data at index 2. And then we are predicting the probability and printing the index of the class. After that, we are printing the test label at index 3. So at index 3, now it is at array 0 and data type is integer 64. You can see one is at index 0 in the array. And later on, we are printing the probability and printing the index of this class. So we can see the probability as 0.987 at index 0 and data type is integer 64. The next task we are doing is building our own data set by collecting images from the internet. So first we have downloaded the CIFAR-10 data set and we loaded the train and test data separately. So X-train and Y-train, X-test and Y-test for CIFAR-10. And then we are selecting the 5 unique classes from 100 classes of CIFAR to train the model. And then we are normalizing the train and test inputs. And then the next major important thing is that we are changing the data type into uint8. So you can see here we used uint8 to change the data type. And then we printed all the unique values of the Y-train value. And you can see it returned as the array of 0 to 4 and data type is of uint8, which is changed. So then we used hot encoding on the Y-train and test labels. One hot encoding on the Y-train and test labels. So, and then we are printing the shape of the train data. You can see the shape of the train data is written as the values shown here. In the next step, we are initializing the sequential model and we use the convolution and dropout layers. After like 8 times of convolution layer, we are using the flatten layer and dropout layer at 20%, as we did in the above task. So at last, the fully connected output layer with 10 units and a softmax activation function is done. Later on, we are compiling the model with loss function as a categorical cross entropy. And we are using the optimizer as Adam and metrics as accuracy. So we are first initializing the epoch and the learning rate at epoch is at 15 and learning rate is at 0.001, and we are fitting the data into the model now. So you can see the values of the epoch written from 1 to 15. And then we are plotting the training accuracy and training loss and value accuracy, the graph shown here between epoch and loss. So on x-axis is epoch, and on x-axis we are taking the loss, and y-axis we took the epoch. Yeah, you can see it in the graph shown here. And then we are saving the model and we are loading the saved model. So after the model is loaded, we are predicting on some test images, and we are printing the test label at index 0. You can see it written as the output at array, array index at 1, and data type of is at float 32. And then we are predicting the probability and printing the predicted test label index, and which return the output as array 0 and data type in 64, and the value is 0.033011. At last we are printing the test label at index 1, and you can see now data type is float 32, and the array returned at 1 in the position of 4 at index 4. And then we are predicting the probability and printing the predicted test label index, which returned a value of 0.431, and at array at position 2, and data type is at integer 64. So from above we can see that model has wrongly predicted the label as 2 instead of 3. That's it.
Yeah, very good. Thank you.
Thank you, Professor.